There are some important pieces of information that we often want to find out about linear graphs, and the first of those is the point where the graph crosses the axes, the x and the y axes. So we call these the intercepts. So remember this being the y-axis and the x-axis. So this point here on our graph would be what we call the y-intercept, because that is where our linear graph is crossing over the y-axis. So in this case, the y-intercept is 4, and the coordinate is 0, 4, because the x value is 0 and the y value is 4. So our y-intercept is where the graph crosses the y-axis. So where it crosses the x-axis is the x-intercept. So in this case, the x-intercept is at -3. The coordinate is -3, 0, because we go across to x equals -3 and y equals 0. So the y-intercept occurs where the x-coordinate is 0. The x-intercept occurs where the y-coordinate is 0. So that can help you to find the coordinates. You can substitute x equals 0 or y equals 0 into the rule to find the coordinates, or you can also find them by looking at the graph and working out the point. A second feature of linear graphs that we often want to find is the gradient of the graph. So that refers to the slope of the line. So if the graph is sloping upwards, so it's going uphill, going from left to right, we would say that the graph has a positive gradient. If it's sloping downwards, so it's going downhill from left to right, we would say that the graph has a negative gradient. So positive, the slope goes upwards; negative, the slope goes downwards. There's a few special cases with gradients. Let's look at this rule. Say we had the rule y equals 0x plus 3. So if we wanted to plot the graph of this rule, if we substitute in any value for x, whatever x is, we're multiplying it by 0. So this term just becomes 0. So it's just y equals 0 plus 3. So y will always equal 3, no matter what value for x we substitute in. It just becomes 0. So the rule is y equals 3. So when we plot that rule on the Cartesian plane, we just end up with a horizontal line going through the point y equals 3. So we can just write that rule as y equals 3. We can get rid of the term 0x. And we say in this case that the gradient is 0. Okay, it's not positive or negative. For just a straight horizontal line, we say that the gradient is 0. So this graph has a y-intercept here at y equals 3, but it has no x-intercept. It would never intersect with the x-axis because it runs parallel to the x-axis. So it has a y-intercept but no x-intercept. Another special case is if we take the rule x equals 2. So no matter what the y value is, x always equals 2. So if we were to plot these values on the Cartesian plane, we end up with a vertical line running through x equals 2. So no matter what the y coordinate is, the x is always equal to 2. In this case, we say that the gradient is undefined. Okay? We can't define it, we can't work it out. So we call the gradient undefined. So this straight vertical line has an x-intercept because it goes through the x-axis at x equals 2. but it would not have a y-intercept. Because it's running parallel to the y-axis, it'll never intersect that axis, so it doesn't have a y-intercept. So just to review gradients, we've talked about 4 different types of gradients. A positive gradient, where the linear graph slopes upwards from left to right. A negative gradient, when it slopes downwards. A zero gradient, when it's a horizontal line cutting through the y-axis. And an undefined gradient, when it's a vertical line that cuts through the x-axis. So this is just a summary of Unit 6.2. It's come straight from the textbook. So I won't read through it, but you can read through this information just to summarize what we've covered in Unit 6.2.